Hi students, welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic we are going to discuss is from chapter 6, electromagnetic induction. Already 7 questions for this problem is given in previous session, and now we are going to solve the problem for this session. Let's move to first problem. A coil of 800 tons effective area 0.05 meter square is kept perpendicular to a magnetic field 5 into 10 power minus 5 Tesla. When the plane of the coil is rotated by 90 degree around any of its coplanar axis in 0.1 second, the EMF induced in the coil will be dash. In option A, B, C, D, I think you have found the answer. Which is the correct option? Yes, option C, 0.02 volt is the correct answer. Let's discuss how to get this answer. Problem used here is E equal to minus d phi by dt. This is from laws of electromagnetic induction. E equal to minus d phi by dt. Phi is a magnetic flux and phi equal to NBA cos theta. Phi equal to NBA cos theta. And here there may be a change in the area of a coil, or maybe change in the magnetic induction, or change in the orientation. In these three, any one of this will be changed. Here, change in the orientation of a coil, that is theta is changing, other things constant. So NBA you can take outside, and cos theta 2 minus cos theta 1, that is d theta by dt. That's a d by dt, or change in cos theta value is cos theta 2 minus cos theta 1. And plane of the coil is rotated by 90 degree. So here theta is 90 degree and theta 1 is 0. And substituting this here, E equal to N is given 800 tons. 800 into B. B is 5 into 10 power minus 5 Tesla. So 5 into 10 power minus 5. And A. A is the area of coil 0.05 meter square. It's already in SI unit, so no need to convert. Directly you can substitute into 0.05 by dt. Change in time is 0.1 second. 0.1. And cos theta 2 and minus is there already. And here cos theta 2 is 0 minus 1. Minus getting cancelled gives plus. And 800 into 5 into 5. To simplify this, then E equal to minus of minus plus into 8540, then 4000 into 0.05 into 0.1 is 10 power minus 1, comes up 10 power plus 1, so into 10 power minus 4, and 4 5 20. So use 20 3 zeros, and these 2 0 means point here, into 10 power minus 4. So that gives equal to 0.02 volts. 0.02 volt, that is option C is the correct answer. Let's move to next problem. A coil of resistance 400 ohm is placed in a magnetic field. If the magnetic flux phi in Weber linked with the coil varies with time t second, and phi is given as phi equal to 50 t square plus 4. The current in the coil at t equal to 2 second is dash. Option A, B, C, D is given. I think you found the answer as usual. Option A is the correct answer. First formula used is E equal to d phi by dt, and phi is given 50 t square plus 4. Then differentiate phi with respect to time t. Then E equal to d phi by dt, d phi by dt equal to 50 t square. If differentiate, then 50 into 2 t, that is 100 t, and 4 is constant, so plus 0, 100 t. Now the time at t equal to 2 second. So EMF E at t equal to 2 second is equal to 100 into 2 gives 200 units. What's the unit of EMF? Unit of EMF is volts. 200 volts. Then next to formula I, because you want to find a current I. I equal to E by R. E by R from Ohm's law. E value is 200 and R is given 400 ohm. Then these two 0, 2 0 getting cancelled. 2 by 4 that is equal to 1 by 2. 1 by 2 is 0.5. Therefore, I equal to 0.5 ampere. That is option E. Option A is the correct answer. Next, we'll move to problem number 3. A conducting circular loop is placed in a uniform magnetic field B equal to 0.025 Tesla with its plane perpendicular to the loop. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. The induced EMF when the radius is 2 centimeter is dash. Option A, B, C, D. The option B is the correct answer. Formula used here is E equal to minus d phi by dt, same electromagnetic induction, laws of electromagnetic induction formula only. That is, induced EMF is equal to rate of change of magnetic flux. And here there will be a change in the area of a coil. Already we said that there may be a change in the magnetic induction as dB by dt, or change in the area as dA by dt, or change in the orientation as d theta by dt. D theta by dt already we discussed. And now here change in area of the coil. So here change in area is dA by dt, and it's a circular loop. Area of a circle is pi r square. So d pi r square by dt. And here pi is constant, take out of the integration. Then this is equal to b into pi into r square. So differentiate r square, 2r into dr by dt. 2r into dr by dt. And b is given 0.05 Tesla. R is given 2 centimeter. Centimeter convert into meter. And dr by dt 1 millimeter per second. Millimeter convert into meter. Substitute and simplify, we will get an answer. E equal to b value is 0.025. 0.025 into pi 3.14, you can substitute, but see in option already it's mentioned in terms of pi. So don't disturb pi. Keep pi as it is, last we will keep. And then 2 into 2 into r. Or 2 centimeter convert into meter. That is 2 into 10 power minus 2 meter. And dr by dt. Dr by dt is 1 millimeter per second. Millimeter convert into meter into 10 power minus 3 or 10 power minus 2. Yes, 10 power minus 3. So 1 into 10 power minus 3. And pi is there, keep pi as it is. I said don't disturb the pi. Keep pi as it is. Then 2 into 2, 4. 4 into 25, 100. 4 into 0.25 is 0.1. Into 10 power minus 2, 10 power minus 3, that is 10 power minus 5 pi. And answer is given in terms of microvolt. So bring this into microvolt. So 0.1 if you convert into micro means 1 micro is equal to 10 power minus 6. So 1 into 10 power minus 6. 1 into 10 power minus 6 pi. That is pi into 10 power minus 6. Pi into 10 power minus 6 volts. 1 microvolt equal to 10 power minus 6. So pi microvolt. Microvolt. So pi microvolt is the answer. Option B. Option B is the correct answer. Let's move to problem number 4. A rectangular coil of 20 turns and area of cross section 25 square centimeter as a resistance of 100 ohm. If a magnetic field which is perpendicular to the plane of coil changes at a rate of 1000 T by S. What is T by S? Tesla per second. Then the current in the coil is dash. In option A, B, C, D, which is the correct option? C is the correct option. Here also same, EMF induced equal to rate of change of magnetic flux, and here out of NBA theta, here B, change in B value is takes place. That is rate of change of magnetic induction. Previously we discussed rate of change of area dA by dt. Before that d theta by dt, change in orientation. Now dB by dt, change in magnetic induction. And here dB by dt is given 1000 Tesla per second. It's already in SI unit, no problem. And n is given. What's the value of n? 20 turns. Substitute that. N equal to 20. Area is already given as directly 25, but in square centimeter. Square centimeter means centimeter square. Convert centimeter square into meter square. That is into 10 power minus 2 whole power 2. That is into 10 power minus 4. So into 25 into 10 power minus 4. And dB by dt is given 1000. Simplify this. Then your E equal to 20 into 25. That is, this is 50, 500. 500 into 10 power minus 4, 10 power 3, 10 power minus 1 gives 50. 50 volts. Substitute this value here because we want to find current only. Current I equal to E by R. And E equal to 50. And R is resistance given 100. Then on simplifying, we will get 0.5 ampere. That is 0, 0 getting cancelled. 0.5 ampere is the current in the coil. Option C is the correct answer. Let's move to problem number 5. Fifth problem, a magnetic field of 2 into 10 power minus 2 Tesla acts at right angles to a coil of area 100 centimeters square with 50 turns. The average EMF induced in the coil is 0.1 volt when it is removed from the field in t second. The value of t is you want to find. Here, change in the magnetic flux, that is phi 2 minus phi 1. When it is removed means phi 2 equal to 0 and phi 1 is NBA. And substituting this here, we will get NBA by dt. Then E equal to NBA by dt. Then dt, that is time dt or t only you want to find. Dt equal to NBA by E. NBA by E. So this is our required formula. Dt equal to NBA by E. Then N is given 50 turns. B is given 2 into 10 power minus 2 Tesla. And area 100 centimeter square convert into meter square by E 0.1. Substitute that. Dt equal to N 50 turns. 50 into B. B is 2 into 10 power minus 2. 2 into 10 power minus 2 into A. Area is 100 centimeter square, convert into meter square. That is 100 into 10 power minus 2 whole power 4. That is 10 power minus 4. Divided by E. E is 0.1 equal to 50 into 2, 100. 100 into 100, that is 10 power 2 into 10 power 2, 10 power 4. So 10 power 4 into 10 power minus 2, keep as it is, into 10 power minus 4 by 0.1, I can write as 10 power minus 1. 0.1 as 10 power minus 1. Fifth problem, a magnetic field of 2 into 10 power minus 2 Tesla acts at right angles to a coil of area 100 centimeter square with 50 turns. The average EMF induced in the coil is 0.1 volt. When it is removed from the field in t second, the value of t is you want to find. Option B, 0.1 second is the correct answer. Here also, E equal to d phi by dt only. Here, change in the magnetic flux itself. E equal to d phi 1 by dt minus d phi 2 by dt. There is a d by dt of phi 2 minus phi 1. And here, when it is removed means phi 2 is 0. And therefore, we will get only NBA by dt. E equal to NBA by dt. From that, dt equal to means NBA by E. So, our required formula is dt equal to NBA by E. And substitute the value of N, that is 50 turns. And B, 2 into 10 power minus 2 Tesla. And A, area 100 centimeter square, convert into meter square. That is 100 into 10 power minus 2 whole power 2, that is 100 into 10 power minus 4 divided by E. E value is 0.1 volt divided by 0.1. And 50 into 2, 100, that is 10 power 2. And here another 100, 10 power 2. So 10 power 4. 10 power minus 2 into 10 power minus 4 by 0.1 we can write 10 power minus 1. This 10 power plus 4, 10 power minus 4 getting cancelled. And 10 power minus 1 comes up 10 power plus 1. 10 power plus 1 into 10 power minus 2. Then dt or as per question t equal to 10 power minus 2 into 10 power plus 1 is 10 power minus 1. It's nothing but 1 by 10 or 0.1 equal to 0.1 second. That is option B. Option B is the correct answer. Let's move to sixth problem. A conductor of length 0.4 meter is moving with a speed of 7 meter per second perpendicular to a magnetic field of intensity, that is magnetic field intensity 0.9 Weber per meter square. The induced EMF across the conductor is dash. Which option is correct answer? Yes, option B is the correct answer. This also comes under change in the area of a coil. And change in the area of the coil after simplification, we will get E equal to BLV. B is the magnetic field intensity. L is the length of the conductor. and V is the speed or velocity. Then all the values are given directly. B is given 0.9 Weber. Therefore, E equal to 0.9 into L. L is 0.4 meter. Is already in SI unit. So 0.4 into V. V is 7 meter per second. That also in SI unit into 7. And by simplifying this, we will get E equal to 9436 and 0.36 into 7. We will get 2.52. 2.52 volts. Very direct answer. So this is option B. Option B is the correct answer. Let's move to seventh question, last question. The magnetic potential energy stored in a certain inductor is 25 millijoules. Energy or potential energy is 25 millijoules. When the current in the inductor is 60 milliampere, then the inductance value, inductor of the inductance you want to find. Formula here is potential energy is U equal to of Li square. And if you simplify for L equal to 2U by I square. And see, U is a potential energy given in millijoules, convert into joules. Milli is equal to 10 power minus 3. So substitute this value here equal to 2 into U value 25 into 10 power minus 3 divided by I square. I value is 60 milliampere. This also convert into ampere. So 60 into 10 power minus 3. 60 into 10 power minus 3 whole square. Then U equal to 2 into 25 into 10 power minus 3. Why I am keeping as it is? Just to simplify. Divided by 60 square. 60 square, 3600 already we know. Instead of that, if you simplify as it is, 60 into 60 into 10 power minus 3 whole power 2, 10 power minus 6. Then use 2 table, 2, 3, so 230 and 5, 525 and 5, 630. Then what's the remaining thing here? It is equal to 5 into 10 power minus 3 divided by 6, 636 into the 10 I am taking here becomes 10 power minus 5. 10 power minus 5 comes up 10 power plus 5. 10 power minus 3 into 10 power plus 5 is 10 power 2. That is 5 into 100, that is 500. 500 by 36. 500 by 36, if you simplify with using 6 table and another 6 table, you will get 13.89. Therefore, U equal to 13.89 H. What is H? H is a Henry. Unit of inductance, SI unit of inductance is Henry. So 13.89 Henry, option D is the correct answer. Okay, thank you students. And the same way, next chapter questions we will give next session and solution in next session. Thank you students.